The last example wants us to create the equation given the graph. So we have to find the amplitude, we have to find the axis line, the amp line, that's what I call it. We have to find if there has been a phase shift left or right, and we have to decide what kind of graph we're going to use. So if we were going to use a sine graph, we I'd like to see like a solid starting point on it, and I don't really see like that would be where the starting point would be, but I don't have enough of the graph to base the rest of my information off of it. So I don't know if we can use sine. I'm going to use cosine, and I'm going to use that as my first point. Now, usually cos should start high, so I'm going to have a vertical reflection in the y-axis, sorry, in the x-axis to get that point down there instead of starting high. So let's look at what we know. This is also a little bit of a tricky graph if you're looking at the values that are given. It looks like the top of the graph happens at y equals 25, and then the bottom of the graph is not nice. This one is happening right there. So we've got to look at our scale. This is going 10 to something to 15. That means every two boxes is worth 5. So each box is worth 2.5. So this line right here is at 12.5. If it's just above that line, I'm going to assume it's hitting at 13. So this is at 13, and this one's at 25. Okay, that's good to know. I could use that information too. This is not parallel, and there we go. Still not parallel. There we go. Now I feel better about that. Okay, I could use that information to find out what my amp is and where my amp line is. So if I want to know what my amplitude is, it's basically the difference of those two values divided by 2 because it's halfway. So amp is going to be 25 minus 13 divided by 2. 25, 15, 14, 13, 12. 12 over 2, which is 6. So from our amplitude is 6, so our A value is 6. That means from 13, we're going up 6, and from 25, we're going down 6 to find out where our amp line is. So amp line, that's our C value. That's just your vertical translation up or down. I'm going to go 25 minus 6 gives us 19. And then just to check, 13 plus 6 gives us 19. So we know that our C value is going to be at 19. That's where our amp line is. Amplitude is 6, going up 6 or down 6. Okay. Okay. What else do I need to know? They told us the period is a 24-hour situation. So we have to find out our K value. Let's go back over here. Period. If we're given period and we're trying to find K, we're going to use that. K equals 2 pi over period. So K equals 2 pi over our period, which is 24. That could be simplified to pi over 12. So our K value is pi over 12. And then we have to decide, has there been a horizontal phase shift left or right? If this is the first coordinate of the cosine graph, which is usually supposed to be up there, that is supposed to happen on our y-axis. So it has been moved to the right 5 spaces or units. So that is a horizontal translation to the right by 5, which would mean our D value is actually -5 because when we put it into the equation, it goes backwards. And our amp has to be negative because we're going to start low. Okay, so this could be an equation that fits this data. Negative amplitude, sine, no, we're doing cosine, Megan. Cos, bracket k value, pi over 12, close bracket, x phase shift, minus 5, close bracket, vertical translation 19. There are other equations that you could come up with that. Like another person might want to go, instead of using this as their first point, they might want to use that as their first point, which is, according to this, this is still 5 in between each. So this would, like, this value right here is 17.5. I'd say this value hits at 17. They wouldn't have a negative value because they're starting up high. Their phase shift, though, instead of being right 5 spaces, would be right 17 spaces. So another way someone could write this would be this. F of x, the amp is going to be the same. It's going to be positive this time, though, because we're not worrying about there being a flipped point. We're just going straight across to the top point. We're still doing cosine. We're still doing pi over 12 because the period doesn't change, but we're going to horizontally translate 17 to the right instead of doing. So both of those mean the same graph. It's just what do you want to do? So don't be surprised in the back of the textbook if some of them are a little bit different. Okay. So